Alrighty, so sphere has a radius of 9 feet, so r equals 9, and it's changing. So we would call that change drdt, but don't have to worry about that right now. So they're asking for the volume formula. So volume of a sphere would be 4/3 pi r cubed, and the surface area of a sphere would be 4 pi r squared. Now, they're also asking for the change. So to find the change, you have to do the derivative. And the change in the volume, we'd call that dv dt. And the 4/3 pi is a constant multiplier, so it's just going to be hanging out. And the derivative of r cubed would be 3r squared. And because it's with respect to time, we need to include that dr dt. So I could simplify it and make it look a little bit prettier. dv dt equals, the 3's cancel out. Boo, boo. And I have 4 pi r squared dr dt. And then over here, the derivative of the surface area, let's just call it that, would be equal to, now, 4 pi is a constant multiplier, and the derivative of r squared would be 2r dr dt. So that would mean the 4 would become 8. It would be 8 pi r dr dt. All right. On the next one, it says the diameter is growing at a rate of 1 yard per minute. Now, they're trying to be tricky here by giving us yards. So I know that would be like 3 feet per minute. And that's the diameter growing. So the radius is only going to grow at half of that rate. So we could say that dr dt is equal to 1.5 feet per minute. All right, so the change of the volume, we already have the formula. dv dt equals 4 pi r squared dr dt. And now we could plug in the values. We know the radius is 9. And we know that the rate of change dr dt is 1.5. So dv dt equals, what's that, 81 times 4. What's 81 times 4? 162 times 1.5. I think it's going to be 486. And the units would be the rate of change of the volume, so cubic feet over time, which was minutes. Cool. Up next, we have the change of surface area. So we used that to talk about the surface area. And we said it was 8 pi. We know the radius is 9, and we know that dr dt is 1.5. So 72 times 1.5 is, I think it's like 108. I could be wrong. I will check. And that was surface area, so square feet over minutes. And I need my pi too. I forgot my pi here, and I should go back and put my pi on the other one. Alrighty, number B, the radius is shrinking at a rate. So shrinking, so I know that dr dt is going to be a negative, and it's going to be a negative 3/4. So the change of volume, dv dt, is going to be 4 pi 9 squared, and this time dr dt is a negative 3/4. So, hey, check this out. The 4 on top and the 4 on bottom cancel out. That's nice. So dv dt is going to be 81 times negative 3 pi. 243. Negative 243 pies. And the units should be cubic feet per minute. So now that this is negative, I know that the volume is decreasing at that rate. On the other side here, change of surface area. And that was 8 pi times 9 times a negative 3/4. Ugh. All right. And math. That's going to be, I think, negative 54 pi. And the units would be square feet per minute. Let me double check. Oh, yeah, that's right. Cool. Number 4 was kind of a neat problem. Rectangular well. So we've got this rectangular well. All right, there it is, my rectangular well. And we're filling it up at a rate of 3 cubic feet per second. So there's a couple reasons that I know that is dV/dt. Number 1, we're filling it. And number 2, the units are cubic feet per second. So I know it's a rate because of the per second. And I know it's the rate of the volume because it's cubic feet. 3 cubic feet per second. All right. Now here's an interesting part. The base of this is always the same. So the base is 6 by 4 and it's 8 feet deep. So 6 by 4. And I know it's 8 feet deep, but the water level is going to be rising. So there's my water. So the height, the water level height is going to be changing, but that 6 by 4 isn't changing. So when I go to talk about the volume and I say that it's length times width times height, the only thing that's changing is the height. The length and the width are constants. So 6 times 4 times h, or 24h. So this one is a lot more simple than it looks because that base is constant. All right. So what do we know? How fast the water is rising is what I want. Oh, it even tells you that some of them are constants. So there's a good little hint. All right. So if this thing's moving, then I know I need to talk about its derivative, its rate of change. And because the 24 is a constant, makes it real easy. It's just going to be 24, and then the derivative of h is dH dt. So nice and simple. And we know that dV dt is 3. So a little bit of math, 3/24 equals dH dt, also known as 1/8. 1/8 equals dH dt. So I would know that the height is changing by 1/8 of a foot per second. That's feet per second. All right, up next, a spherical hot air balloon is being inflated. So spherical, there it is. Boop, boop, boop. Oh, hot air balloon. So it doesn't really look like that. That's just a balloon. Use your imagination, okay? Air is blown into the balloon at a rate, so I like the word rate, and it's 2 cubic feet per second. So I know that is dV dt. I know that because it's air blown into something and because of the units, cubic feet per second. How fast is the radius of the balloon changing? So the radius of the balloon changing would be dr dt. That's what I want to know when the r equals 3. All right. So the formula for a sphere, volume of a sphere is 4/3 pi r cubed. The rate of change of that, the derivative, dV dt, so multiply by 3, power rule. That would cancel out with the bottom 3, so it's 4 pi r squared, and since it's r, it's got to have a dr dt on it. Fantastic. And now let's plug in all the values that we know. We know dV dt is 2. We know that r is 3 at this moment in time. And we got 2 equals 4 times pi times 9, 36 pi dr dt. One little algebra step. 2 over 36 pi equals dr dt. So I could say that dr dt equals 1 over 18 pi, and that would be the units for the radius, so it would be feet per over time, which was seconds. There it is, 1 over 18 pi feet per second. All right, and then how fast is the surface area of the balloon changing at that time? Well, at that time, the surface area is equal to 4 pi r squared. So the derivative of that would be 8 pi r dr dt. And we're plugging values in. So we got, I don't know this. I know the radius is 3, and now I know that dr dt is 1 over 18 pi. Cool. So my pi's are going to cancel out. Bye-bye, pi. And I've got 24 over 18. And that could be reduced maybe 4/3. And the units for surface area is square feet and per second. Cool. Let's take a break there.